Hello, and welcome to the course on discrete structures in computer science. In this clip, I would like to give you an overview of the course, including some of its basic logistics and mechanics. Bear in mind that given the current circumstances, much of this is fairly ad hoc and untested. So let's adapt things that don't work, as well as we need them to, as we go along. First off, this is at its core a course about mathematics, specifically the kind of mathematics that is used in nearly all areas of computer science. The goal of this course is to introduce you to the basic concepts, the terminology, and the notation for these areas of math. While it is not a programming course as such, we will try to connect some of the mathematical notions to practical programming problems in the labs, giving you some hands-on experience and also introducing you to the Clojure programming language. Looking at the contents of the course, we start with some very elementary introduction to sets, followed by a discussion of relations and functions. And then we'll use the concepts we've learned up to that point to look more closely at the mathematical notion of infinity. Infinity is at the core of concepts such as recursion and induction, both of which are central to many parts of computing. We'll then look at graphs, a particular kind of structure that pervades nearly every subfield in computer science and that has a close relationship with mathematical relations. And then at trees, which are a class of graphs with particularly useful properties for some applications. Much of the material in this course can be found in the textbook, Sets, Logic and Math for Computing, or SLAM for short. While it is not required reading, it does provide additional depth and background to the topics discussed in the lectures. In addition to the printed copy, there's also an electronic version free to download inside the university network. This version of the course, adapted for distance learning, comprises a sequence of video clips containing the lectures. They are arranged by topic, and for each topic there are take-home exercises, many of which taken from past exams. These materials are intended for home study. We'll also meet online in video conference calls to discuss any issues, questions, comments you might have regarding the material or the logistics of the course itself. In addition, there's supporting material for background study, first among them the textbook, of course, as well as other references I shall place on the course webpage. The practical part of the course is represented by the labs. The labs are small programming tasks in a language called Clojure. In order to help you familiarize yourself with that language, there will be a little programming contest in the early weeks of the course before the labs begin. This is the proposed way of learning in this course. At home, you should watch the video clips that I publish as the course goes on and do the corresponding exercises. If you run into any trouble with the exercises, please bring this to me on either Piazza or one of the Q&A sessions so we can debug the problem. Once all those matters have been sorted out, if you have any further questions, also ask them on Piazza or during one of our online sessions. Otherwise, just go to the next topic. This is the current schedule. The slots that used to be lectures and seminars in TimeEdit are now all Q&A sessions. The more questions that are relevant to you and your understanding of the material you bring to these sessions, the better. And keep in mind that any question you have about the material is quite possibly one that someone else is wondering about too. So if we can discuss them in one of those calls or on Piazza, we might be helping others. Piazza, incidentally, is the forum platform we use to discuss the material in the course. It has LaTeX-like support for math text, permits anonymous posting, and allows you to interact directly with each other. It is also what I'm planning to use to distribute the material, specifically the videos, the slides, the exercises, the solutions, and the labs. There'll also be a little programming contest to allow you to get your feet wet with Clojure. I'll publish the details of this in a short while. During the lectures, some material will be marked with sidebars like this. This denotes material that isn't essential and that won't be tested in an exam. The reason to talk about it anyway is that it might help understand other parts of the course or illustrate or contextualize a certain point. As for the exam, we're still in the process of figuring out how exactly to handle the logistics of this in the time of distance learning. But the principal rules used to be as follows, and I will try to keep them that way. First, the exam is all math, so there's no Clojure programming. It'll be open books, so that means that you can bring any printed material that you like, including exercises, old exams, the textbook, other books, whatever it is on paper that you care about, cheat sheets, you can bring it. The exam itself may test anything that is being discussed in the lectures. The lectures define essentially the scope of the course, excluding, of course, the sidebar material. Finally, feedback. This is the first time this course is done in this way, and there was not much time to prepare. So that means that things will go wrong. And because I'm sitting away from it happening, like you all are, I might not necessarily notice that they do. So what I would ask you is to provide me with feedback, because it is essential to make all this work out. Thank you very much. Good luck and enjoy the course.